Hey everyone, welcome to lesson 9.1. This is a new chapter, a new unit, got a new background, got a shamrock here, and let's get started. Your objective is you will be able to find the area of parallelograms. I don't think it's going to be too hard. Parallelograms are nice shapes. Let's get right into it. Alright, so first of all, what is a parallelogram? You've learned about these before, but essentially, it's a four-sided figure with opposite sides are parallel. So remember, parallel are lines that will never connect. So this has opposite sides that are parallel. And as you can see, a rectangle is a parallelogram because the opposite sides are parallel. These will never touch, and these will never touch. And they're a four-sided figure. So that's a parallelogram. So is a square. Those two lines will never touch because they're parallel, and those will never touch. The opposite sides will never touch. So yes, that is a square, but it's also a parallelogram. And this is a rhombus, which is how you'll see most of your parallelograms looking something like this in your book. Opposite sides will never touch. All right, they are parallel. These lines will go on forever without touching. So we have to find the area of parallelograms using this formula. It's the same as finding the area for a square, which you've done, or a rectangle. The area is the base times the height. So here's your formula. A equals BH. A for area, B for the base, H for the height. All right, so this is the base of this parallelogram, and this is the height, okay? This will not be my height. So here's the confusing part. This line right here is not my height. The height is a straight line from the base to the top. So I'm just going to read this right here. The base can be any one of its sides. So right now, this is my base, but if I turn my figure, let me see if I could do this. If I turn my figure, I could have, if I make it kind of straight, this be my base now, okay? I can keep turning it and find different bases. I have a different base on the bottom now, different base. So I'm going to put it back to where it was, but I mean, all of these could be my bases if I just kind of turn it, or I could say this is my base up here too without turning it. But the confusing part with this lesson is finding the height. The height is perpendicular, meaning intersecting, distance from the base side to the opposite side. All right, so here's my base side. My height starts there and goes to the opposite side. So this whole line right here is my height. All right, this is not my height. That's not my height. That's not my height. That's not my height. And this is certainly not my height. All right, but here's my height. This line would be a height. As long as it goes from one base basically to another base vertically intersecting. Those are all my heights. So all I have to do is find the base times the height to find the area, the total inside. All right, so let's find the area of this parallelogram. This is straight out of your book. I already found it, actually. It's 48 square units. So 48 units squared. Let's see how I did this. Well, they don't give me any numbers, but they put it inside of a grid, so I can find the base and the height. So I'm going to count the base. 1, 2, 3, 4, 5, 6. 6 square units is my base. I'll put a 6 down there. Let's check my height. 1, 2, 3, 4, 5, 6, 7, 8. My height is 8 square units. Okay? Notice how I didn't start counting this way because it's not a perfect line. We need to use the line on the inside that they give us. So my area is, well, let's put that formula back in there. Area equals B times H. So that would be area equals, our base was 6, times our height was 8. Here we go. 8, 16, 24. 24 times 2, because that'd be 3 more, is 48. So my area equals 48 units squared, which I already have written over there. Sometimes you'll see it like this in your book, all right? They try to trick you a little bit by giving, well, here's your base down here, which is 20 centimeters. And this is your side right there, but your actual height is 11 centimeters, okay? So let's find the area of this figure. What is 20 times 11? We'll find our area. Okay, let's think about it. What's 20 times 10? 200. 20 times 1 more is 20. 200 plus 20 equals 220. So our area of this figure is 220 centimeters squared. All right, sometimes like in this figure right here, you'll have a base. My base is 9 inches, and my area is 45. But I don't know my height. I have to find my height. So I'm going to plug it in my formula. So I have 45 equals my base times my height. So my area equals 45 equals 9 times h. Just back to a few units ago, how do I solve for h? I got to get it by itself. So since this is multiplying, I divide by 9, and I divide by 9. These 9's cancel out. 45 divided by 9 equals, you guessed it, 5. So my height, 5, equals h, or h equals 5. All right, there it is. Now this is not squared because this is just one of my, this is just my height. If it was my area is squared, unit squared. All right, so you have 2 problems to do, an A and a B. It's only one problem, but I'm giving you an A and a B, so it's essentially 2 problems. You have to find the area of this figure and this figure, okay? There's this little cutoff on the bottom. Let me move it up a little bit so you can see the base. All right, so you'll have to count the square units. Hopefully you could see pretty well. Count these out, and then count the height. Base times height gets your area. You got A and B. Pretty easy, and I'll see you next time. Thank you, and goodbye.